All right. We are going to start doing a bit of a deep dive into Git today. And I know I just did the audio check, but just to make sure everyone's still seeing my screen share, correct?
Yep.
Awesome. Okay. So this is a two-part workshop. This part is probably going to take an hour and a half, if we're lucky, an hour, but realistically, an hour and a half. And this one's going to focus on essentially working with Git solo on a project, though these skills apply to working together as well. And this is really to set you all up to be able to be more Git power users when you dive into your personal projects over the next couple weeks. Before the group projects, we'll focus on collaborating and a feature branch workflow with Git and GitHub, which I know you all have seen many parts of this, so some of this will be review and some of these things will be new. Today, we're going to get under the hood with Git or go into the guts of Git, as I like to say. We're going to learn about what's called the three trees, which is the three places in Git that your code can be, which is, and let's just zoom all the way in here. They like to call it the index, the working tree, and and the repository. Um, or the working directory, index or staging area, which is where code goes when we've added it, and then into the commit history or head for our most recent commit once it's committed. So we're going to talk about the three trees. We're going to learn a bit more about commit hashes and what a ref is in Git and how that relates to a hash, what head is and why it's special. We'll cover force pushing later. And really, this is designed for three main scenarios. I've added code that I don't want to commit, and I haven't committed it yet. How can I safely undo this? I've committed code I don't want, but I haven't pushed it to GitHub yet. How can I safely undo this? And I've committed code and pushed code that I don't want. How can I safely undo this? Right? So those are the main scenarios, and the emphasis here is on safety. Um, I don't know. Have any of you had a Git accident yet? Like, raise your hand if you've either lost code or lost like an hour or more of your life dealing with Git. So I see a couple hands up. Not everyone, which is pretty much expected. They kind of come out of the blue. It's a rite of passage for everyone. I can guarantee you at some point you will encounter something extremely painful with Git. You will either end up losing code or spend like hours of your life trying to get code back or unsnarl a big mess with Git. It's kind of the learning process that every software engineer goes through. And then once you do, you become more cautious, and we all kind of learn by getting our fingers burned. However, to kind of minimize the pain and frustration, especially going into your personal projects, we're going to talk about safe ways to do stuff, workflows that are very practical, and above all, there's really kind of two kinds of programming. Programming where if you mess stuff up, it's not that big a deal. We can change the code and it's fine. And programming where if you mess something up, it can really cause, some lost hours of your life and break stuff. Most of the code we write falls into the, not such a big deal category. Um, Configuration stuff, right? Configuration for operating systems, for installing Postgres, for Bash scripts falls into the second category, as does Git. The golden rule with Git is if you're not 100% sure what a command does, don't run it. Let me say that again because it's really easy to forget. If you're not 100% sure what a command does, press pause, find a buddy, find a TA, find an instructor, get help. Don't run Git commands that you're not certain what they do. Like 90 to 95% certainty is okay. But if you're like, I'm 75% sure, well, 75% of the time that'll work great. Speaking from experience, you don't want to spend 6 hours of your life dealing with that 25% of the time scenario. So Git falls into the category of programming where we can really mess stuff up. Like you could lose code, you could lose a lot of code, you could lose hours or days of work. So just bear that in mind that when it comes to Git, it pays to move slowly and carefully and measure twice, cut once, and so on. And that's kind of the principle behind everything that we're going to cover today. So I shared this link earlier, but let me drop it in the Zoom chat again. If you want to, you can code along. I'm going to move at a somewhat reasonable pace, and we're going to be doing part one of this lecture. You'll probably want to just make a separate repo. Like I've made a separate repo here where I'm putting all the code, but this is what I'm going to follow along with, and I'll try to keep it up here as a reference. They'll be hopping back and forth between this and TL draw as well. What we're also going to be using as sort of a guide is this pretty nifty extension called Git Graph. And it's really useful. Let's see if I can get a link to it. I think that gets the link. That's not the link, but if in extensions you search for Git Graph and you find the one with 9 million installs and you install that one, you'll find it. And so go ahead and install that now on VS Code, please, because it's very useful and we're going to come back to it as we go. Do folks have any questions before we dive in? Okay, awesome. And what I'm going to do is, I'm going to talk through stuff and write some really simple bits of code. And then as our examples get a bit bigger, I have some pre-written code that we're going to use as examples. And it's going to be some Flask code. I'll give you all a bit of a preview for when we get there, just so it's not a surprise. Can everyone see this okay? So it doesn't do anything that fancy. It's a dirt simple Flask app. There's no database. There's a student class. There's a list with some dictionaries that are students and one route. And honestly, I just wanted enough code to have something real for us to play with. And so we'll kind of get to that later. But let's go ahead and let's start talking about Git and some of these concepts. And let me go ahead and pull up my my terminal. So the commands we'll sort of see as we go. The concepts are really where we're going to start, and then we'll check out the scenarios. So let's take a look at the .git directory. I've gone ahead and I've cloned this repo. As you can see, it's empty. As you all may have noticed, if I use the ls-a command to show .files, I see a .git directory here. That directory is what makes this a Git repo. And my shell is telling me on the command prompt here that it's a repo. If I type git status, on branch main, untracked files, which we'll talk about in a minute. If I go ahead and delete that directory, this is no longer a Git repo. All that code is still there, but it's no longer a repo. And let's go ahead and let's delete the README. Let's copy the nodes, the directory up, just in case I do something silly. And let's clone the repo again. Actually, really, because I want the name to be the same. Got my notes there. Let's just delete this directory entirely. Clone it. And I'm back in there. Let me make sure. Yeah, we're good to go. So really, the moral of the story here is this is what makes a normal directory into a repo. When I run git init, in fact, that's like, let me make a directory here named foo. That's what the git init command does, is it creates a .git directory. Almost all git info is stored in the .git directory. You should never delete the .git directory. If you are trying to solve a problem and it involves deleting the .git directory, you're almost certainly doing something wrong, and you should be reaching out to a TA or an instructor for help. And if you're with a TA and they're telling you to delete a .git directory, you guys should reach out to an instructor, which I say not for anyone in particular, but just over numerous cohorts having seen this crop up more than once as a problem solving strategy. I just want to emphasize this. There's almost never a reason you want to do this. We're going to dig into the Git directory more, but I just want to check in and see if folks have any questions thus far. And does all this feel pretty good, pretty review, pretty comfortable territory? Awesome. Let's go ahead and go into this .git directory and see what's in here. There's a lot of interesting stuff. The cat command lets me print out text files, and this config file holds all the configuration information for the repo. This is where if I use some of those commands like git config or git remote, I can change the origin, the URL. Here's the URL to my repo. Many of you change this for the daily assignments from the ones you clone. And you can see here that remote, it's really like a nickname, like a name in an address book. And then here's the address information. You can see here when a branch is created, it's added here. For instance, let's create a branch named foo. And now over here, we have the foo branch in that git config file. I haven't really connected anything from the foo branch on my local Git repo to GitHub yet. Note how for main, there's a remote, but for foo, there's no remote. And if I wanted to, just make a file, now everyone has their Git configured a little differently. Most of you will see this command. Not all of you. I forget the configuration step, but that will, in that config file, set an upstream origin or remote origin, right? To go up from my computer to GitHub in the cloud or whatever other computer we're telling Git to connect to. Because Git was originally designed to sort of be distributed so that we could have maybe multiple Git servers and it doesn't all have to go to one place. And now if I print out that config file, we see that foo has a remote. So that's the config file. There's more stuff here, but those are sort of the main things I wanted to point out. Let me go ahead and let's explore a bit more of the .git directory. But do folks have any questions? Cool. And I'm going to use the git branch command to list the different branches. And I'm going to use the checkout command to check out the branch I want to work on. I want to go back to main. A really nice workflow tip is this dash command means check out the branch you were last on. So I can hop back and forth really easily with that command. And it's really nice because maybe I'm working on main and I need to do git checkout and I make a branch like my special backup, and then I do stuff and then I just hop back to main when I'm done. So let's see what else is inside this .git directory, because there's a lot of interesting stuff. If I print out this head, I see that it's a file, and I can open it up in VS Code too if I want. And in fact, in VS Code, if we wanted to, we could open up the config file. Just because it doesn't have a .txt at the end doesn't mean it's not a text file. It just means that the name of the file doesn't have the dot stuff after it, right? So this is that config file that we were just looking at. And in this head file, it says refs/heads/main. Now, this is interesting for a couple reasons. For one thing, over here, I see a refs directory in this .git directory. And that's intriguing. Let's look inside there and see what we get. And let me undo my Zoom annotator. And there's a bunch of interesting stuff in here, but let's go into the refs directory for a sec and see what we have. There's a heads directory, and lo and behold, for each branch I've created, there's a different file. Let's see here. Oh, I think I'm in the wrong spot. Let's go heads. There we go. My apologies, folks. I got a little confused. Just to reiterate, we're in the .git directory, and inside that in the refs directory, and then inside that in the heads directory. Right? So refs/heads. In fact, same structure that we see here. And now let's see if I can't print this stuff out. There we go. So I could open it up in VS Code too if I want. Let's open up both of these other files. Now, 3 guesses. What is this long string of numbers right here? Not a trick question. If you had to guess, what does this look like?
Is that
A
your
hash.
key?
Not a key.
A hash.
Yeah, exactly. Because where else in Git do you see long strings of letters and numbers? In commit hashes, right? Like if I hop over here and I look at my commit history, well, in fact, here in GitHub, you can click on an individual commit, and here in the URL, you see the hash. And if I want to look at all the commits, the UI always confuses me a bit. There it is. There's only one commit here, but you can see the commit hash, right? And a hash is a name for something that essentially uniquely identifies something else. There's some math that Git runs every time we make a commit that from that code is guaranteed to generate a unique string of letters and numbers that Git can then use to find the code we wrote for that commit, to find that commit. So this is guaranteed to uniquely identify a commit. And so each of these branches has a hash under refs/heads. Right, so let's talk about what refs are and what head is and what commits are. And I'm going to move back a bit, right? We were in refs/heads. Let's back up a step. We see there's remotes and tags. As long as I'm poking around, let's look what's in remotes. And here, interestingly, under remotes, we see just one remote for GitHub, which we have nicknamed origin, and we see this name head, which we see pop up somewhere else, and then this message foo that I believe was my commit message with that commit. And if we move back a level in the .git directory, we're back at the top, and there's some other stuff. There's info, there's logs, objects we might touch on later. The rest of this we're not going to really worry about too much. Let's go ahead and make some commits. And I think the easiest way to start with the commits is let me make a new file and I'm just gonna name it foo.txt. And while I do this, I'm gonna open up I think the VS Code source control so we can see what's going on in here if this has stuff correct. Yeah, and I think this is good. So yeah, we'll actually do it this way. The three trees, there's a working directory, there's an index or a staging index, and there's a commit history. The working directory is whatever's inside my Git repo that hasn't been added or committed. So right now, inside my working directory, is notes.md. And let's say I go ahead and I modify something that's already there, like the README. And now if I type git status, unstaged changes are in the working directory, right? And we can see this over here as well, where the VS Code built-in source control kind of shows us in green everything unstaged. And so now this includes, I'm going to add a little star here to indicate that we're modifying the file. It includes a change to the README file. Now, if I delete this stuff, Git doesn't offer me any sort of protection at all. Let me go ahead and add these things. Let's go ahead and add notes first. And so now notes has moved into the staging area. Right? And README is not staged at all. And now if I add the README change, and I'll bring both of these in here so we have the oval. Both of these are changed, and I see it here in the source control thing. And I get a little bit of protection here. If I check out my other branch, it doesn't care. There's this command, git restore staged. Let me hop back to main. If I did something like git rm notes.md, I get an error. The following file has changes staged in the index. Git won't let me delete that file because it's been staged. So I get a little bit of protection, but I have some rules, some things I could do to override that, and we'll get into that later. So I like to think of this as like if Git is like putting cookies in the oven and baking them, these are all the cookies that are going on the baking tray. You know, they're kind of protected, they're on the baking tray, but they're not baked yet. Right. And just for fun, let's add another change to the README. Right. And now I have another change here to the same file. And Git doesn't care. It cares about commits. Commits are across files. Getting into how Git tracks that is a little out of scope. But it tracks changes across the files, right? So in fact, if I go ahead and let me close this out and delete this, and we do git status, there's a couple modifications here, but if we look at what's staged, that code is still staged that I deleted. And the unchanged stages are in fact the deletions. Right? So again, staging code gives us some protection. And let me go ahead and just undo that change in my file, which should bring us back to parity. And if I do git diff, we can kind of see what's happening here. Though this is compared against the commit. It might be a little easier to go back here to the source control to see the stage changes. And here we can see again, this is the one stage change. So the three trees, right? The three places that Git stores stuff, the working tree or working directory, which is our file system. The index or the staging area. And then when something's committed, it's added to the repo, or what's called the commit history, or often referred to just as head, meaning like the head of the list, the most recent committed thing. And in fact, it's not dramatically different from the idea of a linked list in some ways. And if we hop over here to Git graph, actually, let me open it up with the command palette. So we can see two branches here, the main branch and then this foo branch. And we can see the main branch just has one commit. And here we can see the commit hash. It doesn't have a parent. You can see that there's this metadata and whatever commit message we've added. And in fact, we can even see the individual file changes in that commit. So let's go ahead and commit this code, right? A lot of talking, a lot of looking at things. Let's go ahead and commit. You can use -m to add a commit message. Or as many of you know, and I usually just use -m. If I have a longer commit message, I'm going to put it here. And when you join a software engineering team, people will actually, they might have a standard for how this should be written. And I might need like a title for my little message here. Add notes MD, maybe changes, create notes MD, add thingy. And in fact, there's comments. And in fact, if I want to, I could uncomment these to have that be a part of my commit. And in the comments, there's some metadata telling us what branch this is going to happen on. And I've set up Git to use VS Code as my commit editor. And when I save and quit now, the commit will be done. If I type git status, I see my other unstaged change. If I type git log, I see my two commits. And if I go to git graph, I now see my two commits. And let's just look at the main branch over here. And in fact, we see an uncommitted change here. But up here, we see our new commit. And this interesting message, this commit is included in head. Right? And we have these two commits here. And if I look at the commit hashes in git log, I see for this one, there's this little message in parentheses, head, arrow, main. Right? And let's go ahead and maybe have this. Now, I'm just going to remember that this commit here starts with like 7.3 EC7. Because now let's look at git refs heads main. And lo and behold, it's the same commit, right? It's starting with 7E37. So when you make a new commit to a branch in this .git directory, in this text file, Git saves the commit hash of the most recent commit. And that's what's called head. And that's what Git calls a ref. Right? So a hash uniquely identifies a commit. a ref is like a variable name for a commit. Every commit has a hash. It has to, that's how Git works. Not every commit has a ref. A commit can have more than one ref. And of course, the refs and the hashes go together. So head is a ref pointing to the most recent commit on a branch. There are a couple other common refs. Head is by far the most common. And note that there's multiple heads, right? Because we have multiple branches. There's also something called tagging that you can do. And if I type git tag, you can add a tag to a commit. And as it says down here, and let me grab our pointer, that in fact goes in refs tags. And so that goes in that .git directory as well. And in fact, you can push it up to GitHub. And so if you have like version 5 of your program, you might add a tag to the commit that has version 5. And I have to remember how to add a tag. And so in fact, let me quickly consult ChatGPT to remind me. Because the Git command line interface is not super friendly. And oh, this is, I think, simpler than I thought. And now if I look at git log over there, that git has a tag. In fact, I can do git tag and I've tagged the same commit twice, and there can be a tag message. And if we look in that .git directory, we see those tags. And then I can push those tags up to GitHub if I want. The easiest way to do it, I can do git push origin and then my tag name, or I think I can just do this. And now if I've done that correctly, when we hop over here, I've got those tags that I created, right? And you can create these on GitHub as well. So refs can be used for a number of things, but by far the head commit and tags are the most common. So I've been doing a lot of talking, so I just want to check in with folks and see how people are doing and what's on people's minds. First off, is this useful? One, yes, sir.
Yes, the only thing is I'm wondering what exactly is the tag for? Like, what would you use that for in a practical sense in a work setting? Like, is that used to annotate anything in particular?
Version releases is the most common. Like, the team's been working for months and now we have version 2.5 of our program or something. And in fact, let's go to the React GitHub repo.
So in that message where you put my special tag, you would probably put like the patch notes or something, if I'm understanding that right.
I think so. I mean, like there's also like a release which GitHub has, which is kind of connected to a tag, but not necessarily the same thing. I'm honestly not quite sure what release does, but even in addition to tags, there's often, let's see, do they have a change log? Yeah. Just a text file called changelog, and they'll have the version numbers here of the version changes. And these will correspond to tags, but someone will just write the change log. Because, you know, if we are trying to think of a massive company, if we're Airbnb and we're using React, right? And we have React version 18.1, and then they roll out version 18.2. You know, Airbnb is pretty big. We probably want to look this stuff over to see what's important for us and if it affects anything and if we have to change our code. And if your code base is big enough, like it is at Airbnb, you know, it might take time and effort to migrate to the newer version, right? Usually that's with a major version, like going from 18 to 19. The rule is these tiny ones are like bug fixes and stuff that won't break anything. These are minor changes that shouldn't break anything, but a major change could potentially have breaking changes. So, you know, for a big enough project, you want a change log. And then these correspond to version names, and Git gives us a really nice way to embed into that commit history the version name as well. Does that help answer your question? Yeah, great question. Right, because we have like nice little messages that we can add here, but the change log is like where, like that's where other developers are going to go to read about the version changes. Right, so for all of you, you know, if you want to do versioning for your personal project, that could be a good habit, but it's really icing on the cake. Same for group projects, but it's good to know about. It is a nice way if you want to like kind of impress an engineer, if you get them to look at your repo and you have tags and versioning and a change log, it certainly is going to help your project stand out a bit, you know, relative to say other people applying for the same job who may not have that on their GitHub projects. Because it's just a reflection of the boring stuff that ends up being important for real world engineering. James, yes, sir.
Can you go over the git commit again without the message in the terminal? I'm getting like I can't commit that way right now, or I think I just missed something.
You may have Git in its global configuration set up to not use VS Code, or there's like a special setting in that config to make sure it works right with VS Code. So I think that's a little out of scope of what we're doing right now. But truth be told, have like 80 to 90% of the time, I'm doing it with the -m flag and a short message. So that's perfectly fine.
Okay, cool.
Yeah, totally. Actually, if you want to, what I would recommend looking at later is I linked to a couple good resources here. One is a sort of intermediate Git optional lesson that we used to have that's also sort of a cheat sheet. So I think that can be really useful for folks. The other is though this is covered in InstallFest, like it's probably like this is the command you might need to run. But don't do it now, because like I was saying with Git, you want to move slow and careful. So, but just check that out later. And I would maybe grab a TA or a buddy just to get eyes on it as you go. So another thing I can do, by the way, with commits is let me go ahead and make another commit. Let's grab our graph here. Let's commit these uncommitted changes. Interestingly, and I changed the dot notes as well. What did I change with dot notes? If I do git diff, this shows me the difference between my committed code and my working directory, I think, and the stage changes for whatever file I want. And it looks like I added a bunch of stuff in before I did the change. So let's go ahead and we can kind of watch these changes happen again. So a lot of you have been doing git add dot. Dot will add all files. That's good most of the time. It's not the worst habit to develop, like adding and doing stuff one file at a time. Like let's add the README. Let's add notes. Let's add notes again. There we go. And so now over here, I've got readme MD. I've got more changes to notes MD. And let's give this an oval as well. And this oval, by the way, has moved out, right? It's now been committed and it's the head. And in fact, I think what I'll do over here is let's make ourselves a little TL draw version of this graph. And the important thing is stuff points backwards in Git. Like if I click on this, there we go. This is the commit that I made before. It should be adding a change to our foo commit. Yep. Yeah, I have to navigate this a little bit. But the thing I want to point out is here's the commit hash. And in fact, let me use git log to confirm. 73E78, blah, 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 blah. Yep, the same thing here. This commit has a parent, and that's the hash of, lo and behold, the commit before it. Right? So this is how Git makes this commit history on a branch, is each commit has its parent hash, not unlike sort of like a linked list, or when you think about how all the different branches work together, a tree. So anyway, let's go ahead and let me make a little oval here. And we'll call this initial commit. And it's over here. And what we now know is, in fact, there's like an arrow pointing from head to that initial commit. Yeah, let me close this out. There we go. So we've got our three trees, right? In a Git repo, all code is in one of these three states. And so all the committed code is in the head because it's committed, and the head commit points back to the previous ones on the branch. And in fact, our side branches point back to the main commit, which I'll show in just a minute, I think. Let me go ahead and commit this stuff. And let's just do yet even more readme tweaks. Right, and so now I had moved this stuff into the staging when I did git add. And this is going to get a little messy, but we'll get there. The arrow, I think we're just going to have the arrow live there permanently because the head always points to the most recent commit. Because this is over here. We've committed this new one. And let's add a little message to it. Yet more readme tweaks. And then this one points back here, right? Now let's say I want to change that commit message. I can use git commit -- amend. And this will actually let me change the commit message for something I committed. And I'm going to go ahead and make that change. And now I see that in my git log. Right, and so now this main branch has these three commits, and this one's on the head. Let me go ahead and let's make a file named just foo.txt. And now that's here in the working tree, right? Now, let me go ahead and add it. It's been added. But now, let's say I want to put this on a different branch. And we'll just call this the foo branch. So nothing has really changed. My main branch is the same. If I do git log, I see the head is still the same, but there's something interesting that's happened in the .git directory. In that .git directory, remember we had .git, .refs, .heads. Let's look at the head for main. And that commit message 8EF blah, 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 blah. That should be this one that we just did. No surprise there. But for the foo branch, it has the same head. Right? Can anyone maybe break down what's going on with that? Why did Git do that for us? And this little branch diagram is sort of the key. And let's see if I can't. Does it let me show more than one? Yeah, let's just look at these two branches. And let me go ahead and commit this code and we'll see why. So now, let's see. Let me maybe add a change here to foo. And what I really want is I wanted to get that nice branching diagram. I think I know what I need to do, which is I probably need to hop back to main to do this, right? Because I've just added a couple more commits here. This one's over here. This one points back there. This is main. And if I hop over here, we've in fact made some commits on the foo branch. We have foo txt. And then we added hello. And if I sort of draw my arrows back, and let's make this stuff blue to show it's foo. And let's make this stuff, oh, I don't know, red to show it's main. So this is where that tree and the three trees come from. Because you could imagine if we had more branches branching off of things, we get a tree structure, right? And so that's why we could have two different branches having the same head ref, having that same commit. And if I hop back to main, let's go ahead and add another change here. Let's make a bar.txt file. And note, by the way, foo.txt is gone. It's living somewhere inside that .git directory. In fact, if I hop into .git and I go into objects, somewhere deep in there, that actual code is hiding. And if we look at let's see. Yeah, I don't want to try and hunt around for it. That's probably a little too confusing. And so now we get this nice branching look. Because now I've added another commit here on main. And let me get graph to just update itself. I think there we go. It was a little, the VS Code plugin was a little confused. I don't know if you all can see now, but here we have our nice foo branch, the foo branch. Here's my other foo branch from way earlier, and we can see how these branch off of main. And lo and behold, this commit, its parent points back to the one on main. This commit, its parent points back to the other one. So branches really aren't that special. It's really just the heads of the different branches that matter, because each commit points back to a parent commit, and Git doesn't even know what branch it belongs to. Git just keeps track of the heads and works backwards. Right? Because over here is a head ref. And over here, is a head ref as well. Because if I look at Git refs heads main, and then for the foo branch, they're now two different things, right? And the main head points to this commit that we just made up here. 04832 blah 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 and 04832 blah blah blah. So this is kind of getting under the hood a little bit, but it hopefully maybe even feels a little simple. So I just want to check in and see what people are curious about. If I kind of jumped around too much and lost folks, let me know. How are we feeling? What questions do people have? On a scale of 1 to 10, how do we feel about like head and commit hashes and branches? James, yes, sir.
So I don't know if I'm understanding it 100% yet. Are the branches only important when you add and commit things then? Because that's how it keeps track. Like you can be checked out in any branch and be making edits on your device, and then as soon as you add and commit things, whatever branch you have checked out, that's where it'll start to keep track of things.
Yeah, exactly. Okay. And in fact, let me ask ChatGPT, where does Git track the current branch? And it's going to be somewhere in that .git directory, and it's going to be a ref pointing to a head for whatever branch we've checked out. And lo and behold, it's in fact /head. Because if we look in this .git directory, there's that file head in all caps that, as we've seen, is just a text file without a .txt at the end. And that's literally just some text telling Git what directory to find another ref that then has a hash, right? Because if I do code git refs heads main, we get the commit hash itself, right? So the refs, it's like if you create a variable and then create another variable and you assign the other one to it, and then you have like 3 variables with different names that all point to the same thing. Which I know I said really quickly, but hopefully should resonate with everyone. Yes? That's exactly what refs are. That's all it is. And so when I check out another branch, what's going to happen to git slash head? When I run this command, let's go ahead and clear this. This is what it says now while I'm on the main branch. When I run this command, what is that head file going to say instead? Not a trick question.
Refs heads, the foo branch.
Yeah, exactly. There we go. And so, James, as to your point, this is literally, if we kind of get under the hood, maybe there's some other stuff, but this is the main thing that actually changes when we check out a different branch. Because all Git needs is a pointer to the commit that's most recent that we care about. And it keeps track of that with the refs. And each commit, just like a linked list, points back to the previous commit. Or like nodes in a tree. So what other questions do people have? Because that was a great question, James. So thank you. What else is on people's minds? What questions do y'all have?
When you pull from the main branch, say there's a couple commits on the main branch that you didn't have,
Yeah.
does your head then change? Or is that just adding those, what's happening there with the refs and the heads?
Yeah, great question. Let's go ahead and find out. I'm like 99% sure this is safe, but just for fun, I'll do it on the foo branch. I don't think I ever created it on GitHub, so let's run that command. And let me close this out so we have this here. Let's just look at the foo branch for a moment. Note, by the way, from this perspective, the foo branch, it includes the stuff on main because commits, they just point backwards. Right? It's literally a tree with each commit pointing back to its parent and then just the refs and heads keeping track of the most recent one. So yeah, great question, Owen. Let's see what happens here when we do this. So I pushed code to the foo branch. I'll close these out because I don't care about the pull requests. And we can see here all the commits. And again, from Git's perspective, these commits live on both branches. I haven't pushed main in a while. Now, if I refresh this, I should see these all on main. There we go. Right, so there's shared commits between branches, and that's normal. So as to your question, like what if we're working together and someone else pushes code on this branch? We're kind of get into all the details of this for the next workshop, but a simple way to simulate this is I try to avoid. You can make a commit directly here. I really wish I could make those go away. Like I can go here to any file really and hit this edit this file. I don't recommend doing this. When I do it, it's usually just to change a README. Especially if you're collaborating, though, I would just recommend never doing this because it's just going to cause confusion as you're getting used to this. But Git does let you do it if you want to. We're committing directly to the main branch, right? So this is unsafe. You should not be doing this, but it's good to see it is. And as an example, now, kind of see what do I have in my TL draw world here? Do I have a cloud diagram anywhere? There we go. So here's GitHub. And let's bring GitHub over here. Because there's two Git repos, right? And we have this foo branch. And this now has 3 commits. There was foo.txt, there was hello, and then I made another that did stuff. And we'll just call this I'll call this like we'll just call this more. Really these should be the commit names, but I'm kind of, the diagram is very ad hoc, so just be patient with me. Right, and in fact, the foo branch branches off of main. Right, so all this right here exists in another Git repo on some virtual server in GitHub's cloud. With an addition, right? Update bar.txt. This one I can get the commit message right for. And we're going to have to make the cloud even bigger. It's a big cloud. And I apologize that this text is probably not readable, but hopefully this is good enough to kind of understand the differences between the commits. So that's what happens when we push code to GitHub. And you could do this like if we had our own physical like Linux box server somewhere connected to the internet, which was kind of originally how Git was designed to be used. It was actually created by the guy who created the Linux operating system for managing this massive open source project, which was Linux. On this other Git repo on a server in the cloud, we have this same tree, except with an addition. So let me just check in and see how everyone's feeling about that, because this is an important point. Everyone kind of feel good about this step and the context here? Awesome. Right, so that's push, right? We've been pushing commits from one Git repo to a remote Git repo on another machine over the internet. Now we're going to pull from that same remote machine down to our server. Because right now, my Git repo on my local machine doesn't even know that that commit exists. Let's say I want to find out the status of things on the remote server. Git fetch downloads objects and refs, like the head ref that points to the head of a branch, and tags. It should not actually be pulling down code. Though I could have this wrong, but let's see. This is also how I find out if a new branch has been created, by the way. I have to run git fetch. And it looks like it actually doesn't tell me that foo is behind. I think I'm going to actually go to ChatGPT for help. Git command to check if my local Git repo is up to date. If branch and you don't have to do this, but as long as we're digging into Git, it's good to see. Yeah, I would have thought this is telling me that I'm behind. I'm not sure why it's not. Maybe I have to do git fetch dash dash all. I'll be honest, folks, I would have expected it to tell me that it's behind. But point being, if we look here, both in the Git graph and in our Git log, we see that we have, these foo commits, but we very much don't have. Oh, I know why. I made a mistake. Let's see. Yeah, I updated bar.txt on main. I'm so sorry, folks. Let's try this again. So I wanted to do it on the foo branch, but I ended up doing it on main. And in fact, that's what I was looking for. So this is also why it pays to go slow with Git, because the worst kind of programming error to make is the error of assumption. It's impossible to debug. I made a silly mistake, but then, that bad assumption of what I did, that I made this commit on the other branch, carried me through. So, when things aren't what you expect them to be, it's useful to dig in. And now, because of that fetch command, my local repo knows that it's behind, right? Because it looks at the refs that are up there. And so, as to your point, Owen, Git tells me that we can fast forward. Git conflicts we'll learn about later. A conflict is when you have two commits modifying the same line of code, usually the same line of code or the same file in ways where Git cannot resolve which one is most recent or should be correct. Like maybe like two different letters in a word or something. Git is dumb on purpose because we don't want it to be too smart about this stuff because there's a lot of context. But because these are easy changes to make, and in fact, if I go over here, I mean, this doesn't even, Git does fine. Like if you change a word in a sentence and stuff like that, it actually does fine with a lot of the simple stuff. This one obviously is even easier because we're just adding stuff. And now if I do git pull, fast forward, main has been updated, our head has been updated. The head for main is now this cd 8 blah 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 commit hash from our most recent commit. I think we have maybe time for like, oh, sorry, was there a question? I know that we haven't gotten to like a lot of the bulk of what we're going to cover today, namely dealing with these scenarios of how to safely unstage code, deal with code we've committed, deal with code we've committed and pushed. I think all this digging we've done into the concepts will help us move through this fairly quickly. Do folks want to take a short break or just keep rolling? We could do like a 5-minute break if people want. All right. Any last kind of questions, or maybe is there like a scenario that we can code up and run right now before we break to kind of like help drive this stuff home? All right, cool. So just to recap, and let me kind of hop back to the TL draw. Commits point back to their parent commit using hashes. Hashes are unique. All a branches is a ref, which is just like a variable with a name pointing to a commit. And that commit is the most recent commit on that branch, a head, as in the head of a list versus the tail of a list. And through those simple things and a couple text files, we get these tree structures and the magic of Git. And all code in the Git repo is either in the working tree, which is our directory that has no protection, or it's staged where we get a little, or it's committed where it gets the most. So let's take 5, and then we'll see how to problem solve for a couple scenarios. Sound good? Awesome. Thank you, everyone, and see you all in 5 minutes. Hey folks, how's it going? All right, I know that was a short break. I hope helped you all recharge a bit. I tend to run a bit long and I want to make sure we have enough time to get through the scenarios and there's still a little bit of coding time and break time before the stand downs today, because I know it's a big day. And everyone can hear me okay and see my screen, correct? Cool. And I also just want to point out real quick, so Git basically uses the tree data structure. Excuse me. And like, I'm not super up on my computer science and math, but a tree is a special kind of graph, right? And the AI stuff that you all are learning now with the neural, the neurons and all that stuff, it's using like tensors and matrices, but that's graphs as well, right? And that's where like this computer science stuff, like, linked lists and whatnot, it's not directly applicable, but I think it's really kind of the keys to the kingdom, because technologies might change, but the fundamentals don't. And that's the knowledge and the concepts that lets you learn how these things work at like a deeper level. And the more you do that, like, you'll find it takes a lot of effort to dig down, but then next time you go to something else, you'll be like, oh, okay, this is a tree, I'm familiar with this, and it's easier. And I think that's really how you kind of grow and like level up as a software developer and a programmer. So not short term, but a little more medium term. So let me get off my high horse though, and let's get back to some practical stuff with Git. And let me go ahead and resume the recording and just hop over to what we're gonna do. All right. So we should be recording again. And let's check out some scenarios. Right. And we're going to look at a couple different commands. Git restore, which is a somewhat newer command. Git reset, which kind of does 1,000 things. And we've kind of seen git log and git diff. We've learned about commit hashes. That's the unique string of letters and numbers that uniquely identifies a commit. We've learned that refs is just a fancy word for references for variables to commits, and that head is the ref that points to the most recent commit made on a branch. And we've learned about the 3 trees. We'll see force pushing in a bit, but let's look at, I've staged code, I've added code, I haven't committed it, but I have something I don't want. This is actually going to use git restore. Git is kind of notorious for kind of being kind of arcane on the command line, and the term is overloaded. Like the fact that like git checkout switches between branches and you can use it for other stuff with commits. That git reset does like 1,000 things is not great design, but we've all kind of been stuck with it. So git restore is kind of new. I'm going to kind of dump a lot of code in here so we have something real to look at. And I'll kind of make, I think, a common mistake along the way. So we're going to build this little Flask app. And I don't recommend coding along with this, actually, because I'm going to move a bit faster. I'm going to make a virtual environment. I'm going to name my virtual environment .venv and put it in the directory name, because that's sort of the convention that I follow. I'm going to activate it. I'm going to install Flask and Flask cores so I can write a nice little backend in Flask. I'm going to dump the things I've installed into a requirements.txt file. If I look at the VS Code source code extension, I can see now I have a number of unstaged changes under changes here, right? I probably want a front end and a back end directory. And let's go into the back end directory. And let's just make an app here and let's just call it app.py. And this is where I'm totally copying and pasting. And let's hop back here because I don't think that other view is useful. Right, so this code was written already, so that's not the point of today's exercise. The point is that a dirt simple Flask backend that if I hit it with an HTTP request, it sends back some JSON with a list of students. And let's go ahead and make a README for my backend code and put some instructions in there. And I have this copied as well. And we're on a roll right now, right? I've added a bunch of code. I've made a backend. I can even run it. And it should work. Lo and behold. Let's go ahead and add my code. And now I realize I did something I didn't want to do. What did I do? I added the dot virtual environment file to be staged, right? To go back over here and let's zoom in a bit, right? I've been doing all this stuff. This got moved. We're just going to kind of delete this. I did a whole bunch of changes here. I created a virtual environment directory. I created a backend directory and a file. I created the README. I created a front end directory and I added a requirements.txt file. Right? And then I went ahead and I did git add dot, which staged all those changes. Now, luckily, I realized I goofed here. I don't want to check my virtual environment directory into version control. I don't need to. All you need if you want to run my code is the requirements.txt with those Python dependencies. And you make your own virtual environment directory, right? And that way, like, Flask doesn't eat up space on GitHub. And if there's a new version of Flask, you don't have to worry about it. We just want the dependency file. So I can use the git restore command and git restore, and in particular, git restore dash staged will unstage changes. So what we're going to do is git restore dash stage to unstage changes. But let's talk about safety. And this is a simple example, right? But imagine, it's 3 in the morning and you've been working on your group project for like 12 hours a day. And, you're doing stuff on Git without thinking, and then you make a mistake and delete something and push code. That's the scenario that we're targeting here, where this is a workflow habit where if you do it this way, you will never make the mistake of getting rid of something you don't want. And the rule here is to use Git to do the minimum change we need in a safe way. Because I like that all this other stuff is staged. Because remember, Git gives some protection to staged code. I don't want to unstage everything. I just want to unstage the virtual environment directory. Right? So that's the principle here. And we're going to do git restore staged venv. And as simple as that command is, this is a 100% safe way to unstage code without losing anything. Right? Git restore staged. and we just moved this one thing from here to here. I could have done that, where the dot is the pattern matching for all files. And yes, that works, but then what if I make a mistake with this command? What if like I instead of restore, it's reset, or just the principle is if you're messing with stuff with Git, don't use the dot, like do the minimum targeted change, because our enemy here is our own human error, right? And so this is the workflow habit to build. And similarly, putting like I don't want this stuff back in the working directory. I want the additional protection that Git gives this. So because I just did that one command, and I can run it again, and it won't do anything wrong, right? If I had done git restore staged dot, I suppose I could do that command twice and it wouldn't do anything, but it again, safety is nice. And in fact, what I'm going to go ahead and do is also make a git ignore file and put my Python virtual environment directory in there. And the git ignore file tells Git to pattern match whatever in the git ignore file and ignore it in the working tree, in the working directory. And my virtual environment directory hasn't gone anywhere. It's still there, but Git will ignore it from now until the end of time or until I change the git ignore file. So let's go ahead and, in fact, I think I'm going to do this in 2 separate commits so that the commits are a bit cleaner. Oh, let's do it in one. Let's add the git ignore file. And now that's here. And now we can do git commit class gap initial commit. And I can make a nice message. Just saying what I've done. I can push that code up. So that's our first scenario here where I've staged code, I've added code, and there's part of it that I don't want. And I can use git restore stage to safely unstage those changes. And I just want to check in and see what questions folks have, what steps might be good to go over, because I know I moved pretty quickly through a lot of those steps there. So please let me know what's on your mind.
So before we especially working within a virtual environment, that should be one of the first things we do, right? As far as with our virtual environment, we should put it in a git ignore file, right?
Yeah, and with JavaScript and React projects, the node modules as well.
Okay.
And in fact, when you create a new repo on Git, it'll add a git ignore. I think when you create a new project with Vite for React, it might actually create the git ignore file for you. I'd have to check. But yeah, because the idea is that stuff takes up a lot of space, and also you can specify flexibility in the versions in the dependency file. Like in my package.json, I can say, give me React version 18.2.star. And then if Facebook pushes out version 18.2, .9, and they go from 8 to 9, when I run npm install, it'll grab the most recent one. So there's some complexity that gets in there. But that's why the dependency file is the source of truth for dependencies, not like the node modules directory or the virtual environment directory. Yeah, great question. What else is on people's minds? We feeling pretty good with this git restore staged scenario. Okay, awesome. Let's go ahead and look at another scenario that's a little bit harder. I've committed code and I don't want it, but I haven't pushed it yet, right? And it's increasing levels here Because the Git risk, like now messing with commits is where we start to get into riskier territory because I could potentially delete stuff. Right? So let's go ahead and I'm not going to check out a branch, but let me go ahead and let's install another dependency. Let's update our requirements.txt file. So it's now got python.env in there. Let's go ahead and make a .env file that's going to have some environment variables. And I've just made these up, some imaginary API and the environment that Flask is running in, so it knows if it's in dev or production for tests and error messages and stuff. And like I said, I'm just doing a little bit of copying and pasting here. Our Flask app is now going to use the python.env package. We're just going to add some stuff to load stuff from the .env file and print stuff out. And then what I can do all the way down here when I run my app is check from the env file and either run my app in development mode or production mode, so that when I deploy this onto AWS in the cloud, I just have to change that one value in the .env file and then, get rid of, like, usually it's error messages for developers and stuff. That's the difference. So I'm feeling great, right? I'm working on my personal project. I've been coding for like 10 hours straight, written a bunch of code. I'm going to go ahead and add all my code. I'm going to commit it. I'm really happy with myself. I see I've got it there. And then I realized, oops, I made a cardinal sin. I committed the .env file. Right, and if I kind of open up Git graph and we look at this commit, we see indeed there the .env file that's been committed. And if I push this up to GitHub, it becomes a lot trickier because it's in the commit history on GitHub, and this is the super secret API key, and it's harder to get rid of. So I want to get rid of it now. But I have a lot of other changes in this commit that I worked really hard on that I don't want to get rid of. So once again, we're going to be careful. Because what we have here is this time, I'm going to kind of cheat a little bit and do some deleting. What are my changes? I have changes to @py. I have changes to requirements txt. And then I have the .env file, right? And I wrote all that code and it was in the working tree. I did git add and it got staged. And then I committed it. But I haven't pushed it up to the cloud yet, right? Our cloud over here. So I want to undo this commit, but I want to do it safely and not lose my work. So the way to do this is to move the commit from here to here, because that's safe, right? Because I get some protection with it being staged. And then we can use the git restore stage technique to move that there. And this other code that I have here never goes back into the working directory, which is the most unsafe spot for it, right? Like here, if I try to like delete these files, Git won't let me. I forget exactly what all the protections are, but it does things. And also just this way and this habit and this way of thinking about stuff reduces the chance for human error, which is where most programming errors come from. And that's really my task as a programmer, is building workflows that eliminate possibilities for programmer error, because that's really what it's all about. So we're going from here to here, and then from here to here. And whenever I do this, by the way, I've done this a bunch of times over the years, and half the time I forget the commands, and the other half the time I know the commands, but I double check them first anyway, because you really don't want to get this wrong. You really don't want to get this wrong. This is when you want to move slow. I will take like 15 minutes sometimes to do something really simple like this. I'll look it up. I might read a Stack Overflow post or the docs again. If it's a complicated command, sometimes I type it out in a text file before I put it on the command line. I will pull it up. I do not, at least to get started, I recommend being careful and double checking. So what we're going to do is I need to move the head back, right? I need to go from here to here. There's two ways to do it. Soft means we're not putting it back in the working directory. Soft means it's going from here to here, I believe. There's like git reset hard as well. There's also something called mixed. And I have notes on these that you can refer to later, but soft is safer. And I could have a commit hash here. I could roll this back to whatever commit I wanted, 0, 4, whatever. But this is a chance for human error and programmer error. Instead, I'm going to use a ref. And this tilde, think minus, one commit backwards from the head. Right, so we're going from this command, git reset soft -- head tilde 1 says move the head of this branch, move this ref back from here to here, and take all this stuff in this commit and stick it back into here. Does that make sense to folks? Yes, no, maybe? Cool. Let's run it and watch what happens. So first, let me cat git refs heads main 07 blah blah blah, which is this commit here. We're going to push it back, and it's going to become that commit. So a bunch of things just happened. All this stuff got put into staged that we can see over here. If I type git status, nothing is in the working directory. Nothing is unstaged. It's all over here. And if I print out the head ref, it indeed is now this other commit. So this is great, right? I've reduced the chances for programmer error to be much, much smaller, because even if I make a mistake, I've just moved the code back into staged. I can always recommit it if I realize I did something wrong. And now this is my favorite part. We use the command we just learned, git restore staged, to specifically just move this bit back into the working directory. And so this is a safe process, right? There's a couple extra steps, but if you just build this as a habit, you will eliminate sources of error that can suck up hours of your life and get rid of code you can't get back. And now, what's the command I need to run next to take us home? Not a trick question.
Now you commit it.
Yeah, exactly. And it would help if I added a message to my git commit. Add env. And in fact, let me open up the git ignore and add the .env file to that, which is what we want to do as well. And in fact, what I'm going to do is I'll make a .env example file. And then this is how you document for other programmers what the env file should look like. Is you check into version control a .env example file so they can see what the environment variables should be. But in the .git ignore, we ignore the .env file itself. And this is a pretty short Rust commit message, but I just want to keep the ball rolling. Right. And so now, I didn't go through all the steps, but we had our .git ignore updated. And we added the .env example. And so now we don't have to worry about this happening again, right? And that's become committed, and that's become our head. And it's a new commit hash, by the way, right? Because the actual code gets run through, the code we're committing gets run through a hashing function to generate that hash. And then our env, and I'll make a tiny little box here, in fact. And let's call this the .git ignore. And let's put, the virtual environment directory in there as well. Git ignored. This stuff is in the directory. I guess you could say it's in the working directory, but Git is always going to ignore it. Do you folks have any questions or other parts of that process that might be good to look over again? And how are you feeling? Pretty good about this? Awesome. Yeah, and hopefully this should be straightforward. Like going into the guts of Git helps a lot. And a lot of this stuff is not that complicated once you break it down and kind of see how you can use it together. So we've covered a lot of this stuff. We talked about head -1 and how it's a ref. Now let's talk about, I've committed code, I've pushed it. What do I do? So this one takes a little more thought. Let me go ahead and push this code. And let me go ahead and just for fun, make a couple changes here. We'll add Bob. And let's say I have a typo there that's broken something. And let's say here in the README, I change the README again. Right, so I have these two changes. In fact, I have the git ignore, which I didn't update, so even better. Git diff will show me the difference between the working tree and the most recent commit. I've got my typo. Add another student. Let's go ahead and push that code. And so now we have a bit of a problem. Because I've pushed this code up to my repo. And let me hop back to find my repo. Right, and so here's the commit history up on GitHub. Here's the commit we don't want because it has this bit of broken code that's been pushed up. Let's pretend we're not just going to modify the file, because obviously that would actually be the easiest way to resolve this. Because the scenario here that we want to figure out is, up here in GitHub, we now have this commit that we don't want. So it's not enough like before that I just change it on my local machine, because I also have to push the change up to the repo. And this is where things can get especially dangerous. Because like if I'm pushing up to the repo as I go and I screw up and I do something I don't like, and it's just on my local machine, that's actually a relatively easy fix. Like let's say for some reason I delete, and let me practice what I preach here and make sure I'm up to date. Let's say I delete the whole backend. Let's say I've committed it. And this is just an example. Let's say I've done more. I've deleted requirements.txt. Let's add that. And let's say I also deleted the front end. Right? I've just really messed stuff up. Right? There's stuff that's staged that I don't want. There's stuff in the working directory that I don't want. And even worse, there's a commit that I don't want. So my local repo is, for all intents and purposes, screwed up. But I've been pushing code as I go and ignoring this bad commit. I know that I have stuff in a good state on the remote repo. And I want to blow away basically all the stuff that's happened on this branch, right? This doesn't affect other branches. And I want to use the repo as a source of truth. And that's where reset hard comes in. I give it the remote and the branch name. And Git's going to look at the head of this branch up on GitHub, and it's going to use that as the source of truth and go back in time. It's basically going to blow away this branch on my machine and rebuild it. Working tree, gone. Stuff that's staged, gone. That bad commit, gone. Now, is there any way I can get that code back? No, right? So this is, this is why it's always good to push code to GitHub. So if I screw stuff up locally, I can fix it. But this is also why, Git reset soft was pretty safe. Git reset hard is not at all. If there was something in that bad commit that I needed, or in my working directory, or that I'd staged or added, it's all gone. So this is definitely like don't run it on 5 p.m. on a Friday command. Right? So that's Git reset hard. We still have this problem of add another student, and I need to undo the change I made and push it up. There's two ways to do this. There's actually, let me show the slightly more complicated way, and then we'll see the easier way. So the same way that Git reset hard blows away my local branch and uses the remote one as truth, if I do what's called a force push, I can do the opposite. And if you scroll down here, I think I have yeah. So force pushing, git push -F. this will override the remote branch. So what I'm gonna do is I'm not gonna do this on the main branch. I'm gonna make a new one. Because if I screw up, I don't want to override my remote one. I'm going to do git reset soft head -1. That has all those stages, those changes unstaged. Git restore stage backend app.py. Fix it. Add it back. So what have I done? Here on the main branch, it's the same. This add another student commit that has the bug is still there. But I've created a new branch off of it that has my fix. And we are going to merge onto main this fix main branch. And it can't automatically merge, which is not terribly surprising. So fixing the conflicts is a little out of scope. I'm actually a little surprised there's a conflict here. Actually, if this is the conflict, it's really easy to fix. And in fact, it looks like GitHub Copilot will even explain stuff for me now, which is kind of amazing. Yeah. It looks like the conflict is an app.py. We're gonna see how to do this later. I don't want to get into this today. You never want to fix a merge conflict in the web editor. You always want to do it on VS Code. So this way, although it's sort of better, is a little more complicated. Let me show you the slightly less safe, uglier way of just fixing it on main with a force push, with the understanding that you want to do this with extreme caution, right? And we'll revisit merge conflicts and merging branches for the next part of the workshop. So with main, we have to go through the same process. Reset soft, moves those stage changes, moves that commit into stage changes. We're going to fix that line of code in app.py. I'm going to add a different commit message, fixed, add student in all caps. So here's the dangerous step. Here's what the main branch looks like right now on GitHub. Here's what the main branch looks like right now on my Git repo. They're different, right? Add.env stuff is on both, but this fix add student, that's the difference. I know for sure my local branch is good. I recommend being very careful with this. And to be honest, I also recommend make a backup branch of main before you do this. Because this way, if I really screw it up, I have the old version of main on a backup branch. That's honestly probably the simplest and the best way to use branches Like there's zero cost to making a zillion branches. So whenever you're going to do something destructive, don't hesitate to just make a backup branch. You can always delete it later. Because once we do this, there's no going back. That add another student commit is gone forever, right? And any other differences between these two branches, like whatever was on the remote repo that was not on my local is now gone forever. So that's a force push. And I just want to check in and see if folks have any questions. Okay, awesome. I realize I ran a bit long here. I do apologize. I think there's one more thing I want to show people, and then we'll call it a day. So the force push scenario, obviously you want to avoid. And half the problem was I had like some very different changes in here. I changed the README, I changed app py, I changed the git ignore, all in the same commit. If these were 3 separate commits, I could have fixed this much easier and safer. Let's say I'm writing code and I make a mistake again, which is normal, right? Making mistakes is normal. Programming is about learning how to build in workflows to avoid them and to catch them. I add my code, I don't see the mistake. It would help if I added it. I push the code up and the code is there. And let's say I do something to the README. And I push that up as well. Now, I realize my mistake. This bad commit, I want to get rid of. In this case, I'm not going to modify it. I just want to get rid of it. So this is a slightly different scenario. The good news here is I can use a command called git revert. And if I grab the commit hash, and I can do this 2 ways. I can do git revert head -2. Or I think it might be head -1 to go back, but it's probably a bit safer to just use the commit hash itself. Let's see what this does. Note that Git has added a message for me automatically. Revert the commit message name and the commit hash. I'm going to go ahead and I'm just going to add this to the message. Great. Let's see what this did. It's added a new commit. And if I look at this commit, what does it do? A git revert commit does exactly the opposite of whatever the commit is that we're reverting. It does exactly the opposite. So this is like a really safe, precise operation. I'm not messing with the commit history at all. I'm adding to it. I'm not trying to modify the bad commit. I'm not trying to get rid of the bad commit. I'm pushing another commit that surgically overwrites it. So this is an extremely safe operation. And I still have these good README changes because this revert bad commit only addresses this one. So, if you know you need to undo something, git revert is your friend. And the moral of the story here is make your commits small and focused. Because that way, if you need to revert it or mess with it, it's dramatically easier. Make your commits small and focused. James, yes, sir.
Are all of these steps just to make sure the errors that you make aren't in the commit history, and why is that important?
Great question. This error actually is in the commit history. I've got it right here. And then I get rid of the error right here. What's important actually is modifying the commit history is dangerous, especially once you start collaborating. Because if it's just you, you're only risking your own code. If it's a team of 5, other people pull down the code. If you change the commit history and someone has other commits they haven't changed yet, it gets messy really fast. And also just in terms of programmer error, like Git guarantees that if something is committed, that commit will always be there. So, I can screw stuff up and delete code and rewrite code. And as long as I'm not messing with the commit history, I've got all that there that I can go back in time to. Because we haven't really seen it, but I can move the branch backwards in time. I can actually cherry pick commits. I can compare different commits in the history with each other. There's a lot you can do to manipulate and work with commits. So, that's what Git does for us. It gives us that safety harness. But if I start modifying or deleting commits, that safety harness is lost. And then the risk becomes way higher of eliminating code. And again, for the projects that we've been working on, this is less relevant. Think more of, the assessment was big, right? The assessments are big. Your personal project is probably going to be bigger, and the group project is going to be even bigger. And then for like a real world application, like, again, let's look at React.js just as an example. There's, like thousands of lines of code in here. I mean, there's so many different packages. And here's React DOM. And if we go into the source, there's dozens to hundreds of files and tons of lines of code. And you have like dozens of developers working on this, right? So that's where a commit history is your friend. And that's why once the code base gets bigger, it makes sense to take all these steps to avoid messing with it. Because if I screw up this git revert operation, well, this other commit is still there. And the revert doesn't actually get rid of that in the commit history. Like we can go back to look at that if we need to. Like I can revert a revert if I really want to. And here I am. Oh, I think the revert. I'm not sure if the revert worked, but I may have tried to do that a little too last minute. Or maybe I just need to push it up. No, they both should be there. Git may have just kind of gotten smart in showing this. Let me see if Git graph shows this a bit clearer. Yeah, you can kind of see it. There we go. I think it's like added back in. It's a little hard to tell, but you can actually revert a revert. So yeah, so the Git revert gives you a lot of flexibility, a lot of control, and a lot of safety. Does that help answer your question a bit?
Yeah, I think it does. I guess a follow-up question. Normally,
Yeah.
in the examples you were using, I would like when you make an error like that, what I have been doing is just fixing it and then redoing the add commit push steps
Yep.
and it just like fixes it in the GitHub repo. Is there a reason to not do that and use these extra steps that you have taught us today, or is that still a safe method?
Most of the time you're right. And for this example, I mean, this is a trivial thing to fix. I just go like that, I make a new commit and it's done. Like reverting. So the nice thing about reverting, it's a bit more surgical. It's actually a good question. Let's see what the internet says. Yeah, I don't know if there's a good example there, but the short answer is this is a good example. Let's say we're working on Airbnb, a massive code base, and we decide, and I've just written this bit of code to add this endpoint. And then I realize like I don't need it. And let's say maybe it's like 4 weeks later, and let's say that code is now in production. And every time I change code, it has to go through tests, it has to go through a QA process, it has to be reviewed. Well, I can do that manually and I can write a commit, but there's, potentially mistakes I can make along the way. What if along with this commit, there's also some import statement? And what if I also wrote the code that gets imported there? And what if there's like 5 other files that are touched for this whole feature? Then manually undoing, there's a models file, stuff like that. That becomes a lot harder to manually get rid of this. If I have a commit with work spread across like 5 files, a revert will safely and automatically eliminate exactly that stuff. And as long as I'm doing all this, I might as well just go all the way here. Because on the one hand, I'm saying commit in small chunks and break it up. And then I'm also sort of saying, hey, if you put all the stuff for a feature in a commit, it's easy to revert it. And there's a little bit of a contradiction there. And let's see just a preview of that. There's a command called git rebase. I'm not going to worry about this. There we go. So git rebase lets us combine commits or remove them entirely from the commit history. It's incredibly dangerous. Let's say though I had work that I was doing on app.py. And it's broken right now. But let's say I do something here, just tiny thing 1. Let's say I do something related, import for tiny thing 1, tiny thing 2 related to tiny thing 1. And again, tiny thing 2 for tiny thing 1. And let's say I do something else over here. Right, basically these 3 little commits that all together form one feature. So on the one hand, I have these nice little commits. And if I go to GitHub where I pushed up the code and I look at this branch I've made to look at this commit history. What branch am I on? Oh, I've been doing this on main. That's fine. My apologies. I have these nice tiny commits. And I can see that here with Git graph as well. Right, nice tiny changes. And as we've learned, this means if I need to use git revert or git reset soft, it makes it really easy to do that. And while I'm working on my code, that's really useful. But when it comes time maybe to merge this in to share to others and to push it out, it's actually kind of nice to combine my commits. Also, this is a bit more of a DevOps thing, but if you have a whole feature on one commit and we push it to production and it's live on Airbnb, and then we decide, oh, I screwed up, I don't want this feature at all, that breaks something else, well, then one git revert command will get rid of that whole thing. So I do not recommend doing this, but this is sort of like the workflow that I learned. And actually, let me get rid of this because this is not what I wanted. Git rebase, git rebase or git rebase lets you combine commits. The -I is for interactive, and we have to tell it how many commits we want to look at and combine. And it's this sort of weird syntax of we're modifying this file, and I'm going to change in this text file kick to squash, and that's going to take these two commits and squash them into that one, and these three tiny commits all become one. So I might work in a bunch of tiny little commits with little notes as I go, so if I screw up, it's easy to fix. But when it's code review time and pull request time, I already use rebase interactive. And now if I save and quit this, I get this commit message and I can say feature. Tiny thing. And I, in fact, have all my other messages along the way. And now I, in fact, have all in one commit, all of that work. Now, the danger here is I have modified the commit history. If I screw something up with this, it's gone. And that's on my local repo. And when I push, GitHub complains, as it should, because the commit history is different. So when I'm doing this, I'm not doing this on the main branch. I'm doing it on Adam's feature branch. I would be very, very cautious about doing this on the main branch, because to push my rebased code up to GitHub with these changes to the commit history, I have to force push, right? And you never want to force push on the main branch. If you're collaborating and if you're by yourself, you definitely want to back up, because now all those tiny commits are gone. But now we have this here, and that's to the point earlier about git revert. Now, if I need to undo this, this is actually really easy to do. So the rebase that's a more complex workflow. I would not recommend that right now. If you do it, be very, very careful and make a lot of backup branches along the way. But I figured as long as I was running long, I might as well show you all the whole show, and git rebase is really the last piece of the puzzle when it comes to messing with git commits. There's also cherry pick that lets you grab a commit from another branch and use it. Like I could actually go to the foo branch here, and if I grab this commit hash, I can actually here on the main branch do git cherry pick bar.txt. This looks a little more complicated. We're gonna kill this. I'm gonna make sure everything's in state. Yep. So let's just this is, I think, going to be a better example. So let's pretend someone else, we're all working together and one of you guys has a commit with a bunch of code that I want to use. And in fact, it's this one right here. Well, I can grab the commit hash. And this is where, as you saw just a moment ago, I need to know what the code is and if it's going to cause merge conflicts or not. But as this is a completely separate file from everything else, I don't think this should cause issues. There we go. And so now what I've done really cleanly is I've grabbed a whole commit, doesn't matter what branch it's on, and added it, like picking a cherry from a tree, and that's the cherry pick term. You probably won't need that, but it's kind of cool to see, and I think also illustrates how like flexible and powerful commits are. So that is genuinely the very last thing to look at for today. We've gone through a whole lot. I realize I ran way long, so thank you folks for sticking around. Just to reiterate, in terms of resources, because you want to have references up, everything I went through is here in this doc here. I went ahead and I pinned this to the curriculum org. I'm building a README, but it's also pinned here. So I would check this out. We've looked at part 1. I'll push up the code I wrote, but I don't think it'll be that useful, but it'll be there. And this walks through everything we went over and all the commands. And it also links to this sort of Git cheat sheet that we have from a previous lesson on Git that covers a lot of useful things. Right. And when it comes closer to group project time, we'll do part 2 of this workshop, which will focus on collaborating and pull requests and merge conflicts. So thank you folks very much. I realize this ran a bit long. I think there's probably time for like one question, or if there's a scenario that we want to code up and do, we can with Git. Otherwise, we should probably break so you all can take a break. So what's on people's minds? Questions, thoughts, scenarios you'd like to code up and run? How are we feeling besides zoomed out?
Feeling all right. Yeah, like this was pretty good as far as um recapping on a lot of stuff too with Git. Like I haven't used Git restore in a while. So like restoring files, all that stuff is good catch up for me.
Awesome. Yeah. And towards the end, I realized I burned through a lot of things, but really these 3 scenarios that are laid out here in the workshop curriculum doc, I've added code that I don't want to commit. I've committed code that I don't want, but I haven't pushed it. And I've committed and pushed code that I don't want. That's going to cover 75% of what you'll run into on your personal project. And again, the thing to remember is when in doubt, make a backup branch and push it to GitHub. There's 0 cost. I think that will cover like 75% of the scenarios you'll run into. All the stuff with cherry picking and rebasing is a bit more advanced and more to kind of, I think, flesh out the map more. But this, in terms of what you'll actually be using, these things cover probably at least 50% of it. Cool. Folks, thank you very much. Let me go ahead and stop the recording and then let's break. Okay. The recording